Karl is project manager at Erdwerk. Erdwerk is one of the main player in Germany, developing the geothermal industry there. And actually, there are some huge target for geothermal energy in Germany at the moment. So they are planning hundreds large geothermal installation before 2030 in new strategy. So you have a brave future in front of you. So welcome, and we are looking forward to your presentation.
Yeah, thank you very much. Good. And thank you for the invitation. So today I want to talk about the hydrogeothermal use in Munich, development and exploration strategies as an example of a region where deep geothermal has already been established. As an introduction, I want to show you the role that geothermal plays in Germany at the moment. And if you look at the current numbers in the electricity consumption, renewables already have quite a large share of the total electricity consumption. But you can see that geothermal does not play any role in this. So it's not even worth depicting. And looking at heating and cooling, renewables are still very underrepresented, but at least geothermal does play a role. But most of this will be near surface geothermal and not deep geothermal. So deep geothermal is really still a niche within a niche in Germany. Now these maps show the hydrothermal potential in Germany. And as you can see, it's concentrating on three main areas: the North German basin here, you have the Upper Rhine Valley, and then the Bavarian Molasse Basin, and that's where Munich is situated. But looking at the total numbers of installed electric capacity and the installed thermal output of heat projects, you can see that almost all the installed thermal plants are situated in the Bavarian Molasse Basin. And so there's the question, if there's other large areas where geothermal would be possible, why is it concentrating in Bavaria so much? Of course, it's a complex question, but we try to distill it down to 5 main factors. First, this is highly subjective. And first and foremost, there's a very favorable geology. As I said, the Molasse Basin is situated here in the south of Germany, and it's part of the North Alpine Molasse Basin. Our reservoir is the Malm Reservoir, which is depicted here in light blue, and it crops out in the north here at the Danube River, and then it dips down to the south beneath the Alps. And that means, of course, that also within the reservoir the temperature is increasing, and beneath the city of Munich the temperature would be at around 85 to 120 degrees Celsius. And then at the southern border, it would be at around 150 degrees Celsius. And at the same time, you usually have quite a good permeability within the reservoir, at least in the Munich region, you could say. And from a production well, we usually expect production rates between 50 and more than 100 liters per second. And the water chemistry of the thermal water is very fine, so it's almost drinking water in most cases. And this is a map of the lateral temperature distribution in 3.5 kilometers depth. This is the city of Munich. And as you could see, there's a positive anomaly in the city of Munich and south of the city of Munich. And to the east, there's a negative anomaly. And of course, it's another very favorable feature that the temperature gradient is highest right in the city of Munich, where the energy demand is the highest. So if we take a closer look at the Malm Reservoir has the characteristics of several different types of reservoir. So you have primary matrix porosity in the because it was dolomitized, and so you have matrix porosity, and you have secondary porosity both from fractures and from karst, but karst plays a major role. And our main reservoir is the Upper Malm. As you can see, there's reef facies, which are these And these are our main targets because they have a higher dolomitization and karstification, and then in between you have basin facies, and these usually have a low permeability, so we try to avoid these. Next reason would be economic viability. So low enthalpy geothermal reservoirs like the Malm Reservoir would be perfect for. Oh, now there's a slide missing. Anyway, would be perfect for district heating or space heating. And there was actually a slide showing the energy demand in the European Union, and half of the total energy demand is for heating.
Could you see if it's on the next, if it's the next slide?
Oh yeah, that one.
Yeah.
Yeah. So half of it is for heating. You tend to forget that people mostly think about electricity, but heating is actually half of the energy demand. And so, of course, in a densely populated economic center like Munich, there's a huge heating demand, and so that's a great potential for geothermal. But geothermal is also expensive, you might say. There's a huge investment upfront. So these are real numbers from a successful project in the southwest of Munich. That was with 3 wells, 2 of them drilled in 2002, third one in 2011. And the total drilling cost was 18 million euros. And then, but the larger part of the investment is then for the district heating network, as you can see, which is 45 million euros. And due to the increased energy demand, the same project wants to extend now, and this is the cost estimation for future wells. And as you can see, drilling costs have more than doubled, actually, mainly over the last year. And if we plot the investment and return of investment on a simple graphic, you can see that in the beginning you have this investment for the wells, which is usually just a smaller part than the heating network, and then you have this long investment while you develop your heating network. And so that means that the return of investment is very slow. And usually the break-even point is reached after about 15 to 20 years. And that's why usually geothermal projects in Munich are developed by municipalities and not by private investors, because they're just not that profitable. Now, the reason for success is the public acceptance. 93% of German citizens support the development of green energy in general. That does not mean that they're not against some forms of green energy. But in Munich, we were lucky because all of the first projects were successful, and so we had a lot of positive reporting, and so now in people's heads, geothermal is a good thing, it's a positive thing. And all of these first projects were also municipal projects, and they had a very transparent approach. So there was a lot of education up front. There were it was pure Erdwerk and education and information events, so people were really informed. For example, if there was seismics in the center of the city. And the main topic regarding public acceptance is usually the seismic risk. So all geothermal projects are subject to some seismic risk. You cannot avoid that. But as you can see, again, the Bavarian Molasse Basin is a seismically very quiet area. There's not a lot happening. And so it's not a huge topic here. And of course, you still have to address the risk, but it doesn't play a huge role. If you look at other areas like the Upper Rhine Valley, which actually has a huge geothermal potential, then the public acceptance is the main obstacle, because they already have a lot of natural seismicity, and so people are afraid of induced seismicity. Another reason for success would be the political framework. So for a number of years, there have been subsidies for geothermal projects, and now I won't go into detail on this, but for example, a 3 kilometer deep hydrothermal doublet with 5 megawatt of thermal power installed would be able to receive up to 3 million euros like this. This was valid until 2020, and now since 2022, we have even a lot larger funding, which it's a new funding program, and now up to 40% of the total cost of the strategic network and geothermal wells can be paid for by the state, and up to 50 million euros per project. However, there is no exploration insurance, and that's a big topic again in Munich. This is not too bad because we know the reservoir. There's a lot of wells already, and there's not a huge exploration risk. But that's why it's difficult to establish geothermal in other areas of Germany, because the operator carries the whole exploration risk. And last but not least, a strong developer-planner partnership. In this graph, you can see the drilling time for 1,000 meters of geothermal drilling. And then there are different projects plotted in a time span from 2008 to 2016. You can see how through experience it was possible to really decrease the drilling time. And since the drilling operators are paid on a time basis, that means that the cost for drilling went down by a lot. And yeah, even though you have to add that at the moment, drilling time is not going down anymore. So it's plateauing. So now that I've given you reasons for the success of geothermal in Munich, I want to go into how geothermal developed. So since the early 1900s, there was a lot of exploration activity. You can see here the green dots are hydrocarbon wells for fossil fuels. So many of these are just exploration wells, only some were really exploited then. And then in 1938, it was geothermal water found for the first time to the east of Munich, further to the east here at the Austrian border. But for a really long time, it was not really a topic as an energy source. It was just in very few occasions here in the northeast, it was used for thermal bath. But then in the 1990s, interest in geothermal arose again, and then in the early 2000s, some municipalities around Munich started the first geothermal projects. And back then there was no subsidies for geothermal or no program by the state at all. So actually these were mainly geothermal enthusiasts, and they started the first projects and took a lot of risks with the money of their municipalities actually. But yeah, and that's how exploration strategy looked like back then. So you didn't really have a lot of data. All you had was some really old 2D seismic from oil and gas exploration, and some data from the oil wells. But of course, those didn't reach in until the reservoir. So all we could do was set up in 3D geoinformation systems some simple reservoir models. And yeah, it becomes obvious that there's no sophisticated targeting on geobodies possible with this approach. But all of these projects were successful, and then a huge geothermal boom started, like a gold rush. And then by 2007, like almost the entire, besides the negative temperature anomaly here in the middle, almost the entire Molasse Basin was covered in geothermal permit claims. You can also see that here in the evolution of the annually drilled meters of geothermal wells in the Molasse Basin that are peaking here in 2008. And then the financial crisis hit, and there was the first dry well, so unsuccessful project to the west of Munich, which showed that the reservoir is not that good in the west of Munich. And that means that since then, drilling activity is more or less stable at a lower level. And that's the situation we have today. So to the west, the permits are gone. And to the east, there's the negative temperature anomaly. You have another hotspot in the east of Bavaria that I'm not focusing on, but the main geothermal activity is just in the city of Munich, where the energy demand is the highest. And now that there's a lot of new projects under development, the space here within the city is actually getting scarce. And that's why there was the need for a systematic reservoir management. That was not possible with the approach we had before. And the main driver or driving force between most of the, or a large part of the geothermal projects in Munich is the SWM, which is the Munich city utilities. And they have a large, so this is the entire city of Munich, and all the light blue and deep blue is the district heating network that they have already installed. And they try to run the entire heating network on geothermal until 2040. And so to be able to establish such a reservoir management, they performed a huge 3D seismic campaign in the center and in the south of Munich. And now with this, we were able to put reservoir interpretation into another level. We were able to, over a large area, to map out reef complexes and also map out the basin facies in between the reef complexes. So these are the targets we want to hit and the basin facies that we want to avoid. And instead of the 3D geoinformation systems, software packages like Petrel and Eclipse were established, and a 3D workflow, as of course has been the case in oil and gas for a long time, but it wasn't in geothermal. And this allowed us to put planning on another level and start to plan multi-well projects with many wells drilled from one drill site, and each well really targeting a favorable reservoir facies. And our plan of the SWM would be to cover their geothermal claims in a grid of geothermal wells to extract the maximum heat possible. Now, these are, of course, theoretical drilling locations for a reservoir simulation, and this is how it could look if we covered the claims with multiple projects, like I showed before. And now, actually, this is a plan for the future, but the first one of these multi-well projects, which is this one, the project Schäftlarnstraße, has already been drilled between 2018 and 2020. It was drilled from one drill site, 6 wells, 3 production wells and 3 injection wells. And at a depth of between 3.5 and 4.5 kilometers. And the average output temperature was more than 100 degrees, and the average production rate is over 100 liters per second. So actually our expectations were even exceeded. And now in the coming 5 years, there's a lot of similar projects like this multi-well project in the city area of Munich planned. They're in the pipeline. So yes, I hope next time I present you that geothermal will make up a larger share in the German energy mix. Thank you.
Thank you, Karl. It was really interesting to see what's going on. Walter?
First one is completion wells the diameter.
So first section is usually 20-inch casing, and in the reservoir we drill with 8.5 inch, and then the reservoir is actually left open because the mine reservoir is very stable. So we don't need a. But then in some wells, I think one of the wells, the first one had a perforated liner at 7 inch, and we didn't need it for the rest of the wells.
Yeah.
Please.
Yeah, thank you for the presentation. I was wondering, because you showed these numbers for the wells that you drilled and these huge numbers, could you say something about the total length and the average length of one well?
Which was it, the annual, the timeline of?
Yes, yes. If you know, you have the 8.
Yeah.
I'm just curious about the
That?
Yeah.
So these wells would be, I think, 4,500 meters approximately in length. So yes, so the new wells I know are all between 4,200 and 4,800. The three ones that we expect 40 million. I think the first ones were going to the north, they were a bit shallower, but around 4,000 to 4,500 meters.
Ola, you talk about open systems, open systems, in units.
What do you mean open?
Taking the water, extracting the.
No, we're extracting it and injecting it.
Yes,
So,
that means you have injector wells and production.
Yes.
Yes. But I understand that there are now also closed
those two systems.
systems in unique area.
That's what Ever is doing, right?
Yes.
Yeah, in GeoEnergy, that's something different. I think
It's
we're all really curious what will happen there,
okay.
but it hasn't been established.
It's not in Munich.
It's 50 kilometers south of Munich.
Oh.
This is the area. We have drilled wells in the vicinity. Actually, that was an old Erdwerk project that was then dry.
One question was you mentioned the return temperature was about 100 degrees and 100 liters per the conclusion or last slide. But if you flush for some time, the temperature will be reduced, yeah, in the system, in the production.
So we hope not. So actually, they're planned for at least 50 years without decreasing them for more than 1 degree Celsius. So there shouldn't be a connection between the injector and the production wells. The reservoir is that big. We have a minimum distance of 2 kilometers between the injector and production wells. And so far, there's only one project in 20 years where there has been a connection between a producer and an injector, and in all other projects, the production temperatures have been stable.
Yeah, completely stable.
Yeah.
Yeah. What's that?
Yes, I can start.
Oh yeah.
Sorry.
No. This.
I was just wondering, you talk about production and you also look at storage in any of these projects, or is it only?
Yeah, there's actually for the Shetland project that was just completed in 2020. There's a huge storage plant, but yeah, I can't actually tell you a lot about that because it's now done by the SVM themselves.
We had a second question.
Yeah, it's probably a follow-up on those questions that posed with. So the Garrett's read boreholes. If you targeted the reef, did you end up in basin? Is that why they were drawn?
I don't know. I'm sorry. That was a really long time ago.
Yeah.
So go just to.
That question actually in regards to the choice of targets, to which degree are fault zones of importance? Is the reef fascist dominating over the importance of the fault zone, or in which relation do these two stand to each other?
So actually, we have seen at least in projects really around Munich that faults might rather be sealing than actually be important for permeability. So I think there's up in the southeast. There's one project where we expect a large fault permeability, but in all other projects, usually we're not targeting faults anymore.
Last question.
Going back to the storage quickly. So do you produce these wells at constant rate of power, or do you vary them over the course of the year?
So we usually produce less during the summer.
So is that the goal of the storage then, to produce a constant rate?
Yeah.
We are on board. So thank you, Karl.
Thank you.